think that looks like it's working. Sounds like it's working too. So I am here working on the Nightingale kernel, and I figured it might be interesting to stream it. So I've got a couple of things that I'm working on, and I'm just gonna talk about what I'm doing. So the first thing that I want to try to figure out here is a behavior bug that I'm seeing. So this is just a Linux machine, and on this Linux machine, if I go into interactive cat here, right? So I'm just running the cat program. I can type in, right, hello, it's line buffered, you get input, you get output. And if you have a line that's halfway, that's input, but you haven't hit enter yet, and you hit Control D to end the input stream, that input actually gets sent through to cat. Apparently that doesn't actually terminate you immediately. I thought that would terminate the program immediately, but yeah, so hitting Control D there is flushing the input stream instead of immediately terminating the input stream. And when we run my system, I'm getting different behavior. If I run cat, right, very different cat program, very different backend, but it's doing the same thing. If I say hello, I get hello back. But if I have a half input stream, half input line, and I hit Control D, you can see the whole program just ends right there, because standard input has EOF'd, and there's no, that's it. It just sends EOF. And then what that's also done now is you can't see it, but if I type Control R to re-render the line where the cursor is, you couldn't see this because it was behind the other hello, but that hello didn't go to cat, it actually went to the shell. So it's printed out here in the shell. And the thing that I want to figure out is why. Well, I understand why it's going here. It has to do with my file system code being wrong, but I want to figure out why it's wrong in that way. So this is where a lot of that work is happening. This is where, when you read from the serial device, this is the function that ends up being called, dev serial read. So this is what's actually reading the text. This is what should be reading text from the buffer and putting it into the process. And so that's the one side of this. And the other side of this problem is when you actually receive serial characters is write to serial TTY. So this is where, say, if you press enter, this is the code that notices, hey, this person pressed enter. We're going to let the process know that there's now data available in the buffer. There's now a line of text available. And so it sounds like the thing that we actually want to do. So right now, when you hit Control D, I have this signal EOF, which basically causes the next read to return EOF, and then I wake up the process. It sounds like the thing that I actually want to do is, if there's any data in the buffer, just notify the process. And if there's no data in the buffer, signal an EOF. So, in order to do that, let's see if we have a function to figure out how much data is in a buffer, is in a ring. And it looks like the answer to that question is no. And it looks like it should be very easy to write that function. So let's go ahead and write that function. Ring, len? Ring data len. And buff R with which is literally just going to return our len. I suspect that's correct. Okay. Let's indicate that that function exists. And now let's use it. So if we have data of, what is that? File serial tty. What is this ring? Serial tty to ring. Ring is greater than 0. We just want to wake up that process. Otherwise, we want to tell it that there's no more data coming. So let's remind ourselves what the correct behavior is. The correct behavior is when you press enter, it prints again, and when you hit Control D, you don't get an EOF, but it does print again. And our behavior is, hello, laser kite. I don't know why that is. I hope I can post a link. I can send a link to the project. You should be able to do, if you do ! GitHub, does that, let me try that. That should do that. It does. Yes. Yeah, Nightingale open source operating system. That's, you should see the link there. Welcome. Just trying to fix a bug in my input logic. So, input, it outputs, Control D, that did not work. Did I rebuild? That's another really interesting question. I super did not rebuild. Usually helps if you recompile, or else it's kind of hard. So enter, we still get print again. Control D, still dies. So why would that be? We're pressing Control D, we're waking up the file, or we're waking up the thread, and we're not telling it EOF. I guess there's an interesting question of whether we're actually putting everything in the buffer. Where's the like else case? That, or what are these buffer modes? Do we have documentation on what the buffer modes are? TTY buffer modes. I'm really helpful to myself. So I know that if the buffer mode is 0, whatever that means, we immediately write out. So presumably we're not in buffer mode 0. Presumably we are, I see, okay. So in buffer mode not 0, we're not even writing our output to the ring, we're just keeping it in this kernel internal buffer so that it doesn't touch the file. Why would we do that? We would do that so that if the process gets woken up for some other reason, say it receives a signal, it doesn't read a partially initialized line because it's not there yet. So when you hit Control D, what we need to do is flush all of this out. Something like this, and I will abstract this later because this is really dumb that I have this in like 6 different places. But for the moment, let's see if this will work. Write to the ring, the buffer, the index, and reset the index to 0, then wake up the file. Cat, hello, Control D, still kills it. Why would that kill it? And it's still writing it to the shell. Oh, because the whole thing that we just decided was that the data is not in the ring. So of course there's not going to be anything in the ring. TTY buffer index. If there's anything in the buffer, then we write it to the ring and we notify. And okay, actually, I believe this. I believe that that might be correct. And I believe that that might be correct because I just went down the whole rabbit hole of making all the input and all the output line buffered. So I believe that if I said hello and then hit Control D, we would see that it did read 5 bytes, but that will now be trapped in. Thank you for the follow, Laser Kita. That is now going to be trapped in the IO buffers in libc, right? So libc, so the kernel inside the TTY, the kernel is waiting for you to press enter to send anything to user space at all, and you can see that if I do this, strace is a way to see what processes or sort of what kernel calls are happening back and forth. This is, I mean, the same process works on Linux. It looks a little different. So like if I was to do strace cat on Linux and start typing, you can see the cat program is not receiving any of this data at all. It's just sitting here waiting for this read to finish until I do something like press Control D, and then it all goes through, and then it turns around and writes it. Well, we see the exact same thing on Nightingale. It's sitting here in a read call. I go blah, 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 blah. I press Control D. That read call has succeeded, but it hasn't turned around and written it because now it's not up to the kernel. And actually, you can see the second time it's tried to read only 4074 because it's reading into the same buffer that it just read. Right, it read these bytes and then it's like, well, I want more because I want to give a full line, which isn't really what I want. I'm not entirely sure what buffering mode cat uses correctly. What I'm gonna do to just test my theory is just go into the cat program and set the buffer mode to standard input. Let's set it to, what's the signature, null IO NBF, no buffering, and we'll do the same, oops. We'll do the same thing for output. And now, doesn't quite do what we expect it to do. Hello. Control D. Did I do that at the wrong time? Did I not rebuild? No, I rebuilt. No, that's early. F read, F write, I would expect that to be fine with... No. So cat is reading if you, well, I guess that's kind of annoying that they're both, the internal buffer in libc is 4096 bytes, and I've chosen 4096 bytes for the cat buffer. So let's just make this 1024 to see if we can tell which one is actually reading into. And we can tell that it's the internal buffer in libc, which is surprising considering I just turned off the buffers in libc. So, to the internal buffers in libc. Why would you be reading into the buffer in no buffering mode? Well, fread is going to be our culprit, and for a fread into some buffer with some size and some count for file stream being standard input, if the buffer mode is IONBF, I expect it not to read into the internal buffer. I expect it to read directly into the output buffer. Right? There's no read line into buffer, there's no read into buffer. So I wouldn't expect standard IO to be involved at all. So there's obviously something wrong with that. Maybe I got the signature of set vbuff wrong. Stream buff mode size, buffer mode equals mode. Stream buff mode size. IONBF is the right mode. This is actually probably not going to work. To buffer mode. This is probably not going to work because you don't have the right to look inside of struct file. Does that exist? No. What would I call it? I have a function that was designed to print out a file object so that I could debug this kind of situation, and I don't know. I don't even know if it still exists. I just rewrote all of this code like last week. All right, we'll make one. What would we like to print? File descriptor. Mode equals mode. Dot. Yeah. EOF equals EOF. Dot error equals error. And that's probably good enough for now. What did we say? Stream FD, stream mode, stream EOF, stream error. Oh no, we definitely still need the one thing that I was here to find out, buffer mode. Might be helpful if we actually printed it. print file std_in. We have to tell it that this exists because I'm not putting it in the header. And it prints nothing. Prints, there it is, okay. So standard in, file descriptor 0, that's what I expect. Mode 0, I think I expect that. No error, no EOF, and buffer mode 1. Buffer mode 1 is, actually I think it's in standard io.h, includes standard io.h is ionbf. Okay, so that works. So y is, I guess let's try that. Catting a file and see what kind of, catting a file, it tries to read into a malloc buffer 4096 bytes. Why is it trying to read? And it's trying to, oh, I'm just really stupid. That's, no, sorry. That's not true. In this case, I'm stupid. In this case, it's not reading from standard input, but that's not necessarily true. It's certainly the case in the case that I care about. So what I should do is I should cat the file and I should pipe that to strace cat so that we can see, oh God. Now that looks a lot like line buffering to me. But it reads the whole thing in at once, which it's still this 4096 byte buffer, which is the thing that I don't understand. But it reads it all in at once and it writes it out for some reason a line at a time, even though it's in no buffering mode. That doesn't actually make a lot of sense to me, but where is this 4096 coming from? Is that actually this 4096? Let's just make it more. Nope. And rebuild the entire world, because it turns out when you change standard io.h, that touches everything. And 4112. So it is definitely reading into a libc buffer. So where am I missing something? It's not like I'm not breaking. I mean, I would hope that this is rubber duck debugging, but I'm not seeing it. Should be reading into a buffer of length n times count, which we're super not doing. It's not like I'm not breaking, right? It's not like I'm falling through and doing other things. I guess we could reading with IONBF. I also wouldn't worry about, like, if you're having trouble following this, I know I'm like jumping around, and you also have to remember that I've just been, you can see from this copyright line, I've been moving around this project for a very long time. So, like, please feel free to ask questions if you're not keeping up with me, or if there's anything that's not clear. Don't feel bad about that. Where were we? Right. F reading. Cat. Just cat. So it's not going to print F reading with IONBF, even though we can prove that the stream is IONBF. I guess maybe we should put back the print from before. Am I changing the buffer mode? Do I set vbuff in here elsewhere? Doesn't look like it. Calls the copy function, which copies with fread fwrite. To a buffer that's on the stack, which is also interesting, right? This buffer is going to be way up at OX7 FFF, not in the low numbers. And we're printing that file again. So we can say we can say, why didn't that print? Build. I think I did. Cat. Hello. Why is that not printing file anymore? We did this before. It definitely worked. If we print another file, there it is. Oh gosh. If we print something else, there it is. But if we just do standard in, there it is not. Yep. Yep. Yeah, no, that tracks. That tracks. That does track. That if you don't provide any arguments, it might. Yep. Yeah, that tracks. That's exactly what it is that I'm doing all of this gymnastics down here. But the code that's running is that line right there, copying standard input to standard output, because there are no arguments. See, I glossed over that line because I'm so used to everything else about this I've seen a billion times, right? That huge majority of these programs start something like this, saying if there's only one argument, exit failure, because you need something else. So I was just glossing right over that, and I'm gonna pay the price. All right, Vim has decided to be really inconvenient right now, but that's acceptable. I think I hit caps lock, so it was... No, I didn't hit caps lock. It's just being really weird. There we go. And now, hey, look, it prints the thing. It says F reading with IONBF. Hello. Control D does exactly, well, almost exactly what I said it was gonna do. Almost, because it printed reading with IONBF. So let's kill this. We will make a note that these shouldn't be needed, but they are for now, since my block buffering implementation is a little sketch. This gets us good behavior on CD with complete lines. And we need to get rid of the debugging text in here. And then we need to decide how much I care about making this more pretty, because it's beyond the line maximum. I think we're gonna leave the string, because you're supposed to leave strings, right? So that you can grep for them. You're supposed to leave strings beyond the line maximum. But, I don't know, maybe that'll annoy me more later. Let's make sure it still builds. Let's make sure it runs, since I did kind of hope that it was going to work the way I expected. Control D, it does what I expect. It does what I expect. Hallelujah. And let's examine our diff. We added ring data length. That can be a separate commit, because we didn't end up using it at all. We changed the behavior in kernel TTY. We added, well, that doesn't need to be changed at all. Didn't know what yeah, it was very exciting. So let's fix the last few things that we broke. We broke this. This can be 4096 again. And now let's make like 4 different commits. Add kernel ring buff. Include ng ringbuff.h. Dangerous. Yeah, it depends on the project. Some projects don't care. I know the Linux kernel cares a lot about making sure that you can always take anything that you find in dmessage. Well, I mean, obviously these are like formatted strings, but I can take like starting apply kernel. Well, this is systemd, so that's not really helpful either. I can take this key type registered and I can grep for that, and find exactly where that came from. Yeah, it's I mean, it's supposed to, like I say, it's based on the project, but it can be really helpful. Oh, do I want to know where compiled in revocation X509 certificates are loaded? Well, I can find that just by looking in the kernel source. tell how much data was in a ring, but I didn't, and I needn't. It's useful anyway. What's next? Helpful helper to print a file. Recork. Cat set no IO buffering when copying stood in and stood out. This gives some better UX when handling certain conditions that my std.io buffering does not yet correctly handle. Should be someday. Should be reverted someday. Trademark. And last but not least, the real feature. TTY correct handling of CD. CD is not supposed to blanket kill the stream. It's a flush if there is data remaining in the buffer, and only an EOF. Honestly, that probably means it's not a special case, since returning 0 from a read is an EOF, but I'm going to stick with signal EOF mechanism I already have, since it seems to work. Worth considering in the future. Cool. And that's a real, well, I guess we should probably wait to see that like builds correctly in GitHub Actions, but if so, I think that's a release or a version. 0.12.4. .12.4. CD. How do you get the list of tags? N1 list. There we go. Build is good. So git tag v 12.4-m Cool. So next thing that I want to look at are, sort of in the same vein, are a couple of control characters for the shell. So, right, when you're using a shell, right, if I say like echo hello world or whatever, you've got obviously the ability to go back and forth, but there's also other helpful things, like you can say control K, and I guess it's not so easy to see in Fish. Go over to Bash. If you are using readline and you say control K, well, that gets rid of all the rest of the text to the right. Or if I have text to the left, you can get rid of that with control U. You can use control F and B to move back and forth. And all of this is because when you're using a shell, right, you're really using, essentially it's an Emacs editing environment. But I've been able to implement a couple of those, and I think it would be nice to implement a few more, just to have it be a little closer to reality. And I don't think these are going to be very hard at all. So let's have a look at the shell. Shell gets its own subdirectory because there's actually several things going on. So like this is the main shell process where it reads the couple of options that it has, and then while true, handle one line until that says it's done, and then it's done. Handle one line, which is up here, right? Handle one line is readline interactive or readline simple. Tokenize, parse, and eval. But for today, we're going to be inside, or for right now, we're going to be inside readline interactive, which is where I do the sort of line editable reading of what command you want to run. So like here's where I handle escape sequences. This is where I'm handling arrow keys, because arrow keys are not control characters. They're their own annoying thing, right? When you hit up arrow, you're actually sending back X1B open bracket A, and you have to figure out that, which I don't enjoy. But the control characters are handled down here. And a couple of these are just wrong already. Because I have control N for control N and control H for some reason I used as up and down arrow before I supported up and down arrow. So these just have to go because those are not correct. But like here are probably the two that I use the most, right? Control A is send the control sequence to go to the start of the line and set the cursor to 0. Control E is go to the end of the line, and the way that I'm handling that is go all the way to the beginning of the line and then go state.length toward the end of the line, because I don't know. I mean, I could have done the math for like where is the cursor and moving it around, but this seemed easier. So let's do control F and control B. Those should be really easy. Control F is move forward one character. And control B is move back one character. So those should just be doing exactly the same thing as left and right arrow, which kind of implies that maybe I should factor this. It's 4 lines of code. I mean, it's not like end of the world. I think I am going to factor it, actually. We're going to make a function. Kind of a trivial function, but that's what I'm trying to get in the habit of doing more of, simpler functions so that you can just read what's happening instead of having to like figure it out. So that's going to return a state. Move, let's say, left first. And that's pretty simple. I think C is left. We'll have to double check that. Actually, I think, no, I don't know. C is right and D is left. C is right and D is left. And now that should make this much simpler. Move right state. State equals move left state. And then we can just duplicate that down here. Forward is right. Back is left. And continue so that we don't break through. R re-render. Move to start of line. These maybe should also be factored, but leave that for another time. So let's check that that works. I committed, which means my build system rebuilds everything, all 191 files. And it takes forever because this instance has only one core. World. And they do not work. Those were not N and P, those were F and B. Oh, well, that's not helping. And I have to So that doesn't, for starters, that didn't work. Why didn't that work? I just took the same thing that I already had. If it's C, print C. Oh, because move right and move left have different conditions, and I did not, and move left should be minus equals 1, not plus equals 1, because I just copied the same block twice and hoped that it would work. Moving left. Control B is not going to work because Control B does something different, as you can see. State is a local to read line interactive. You can see it's just defined here. But it lives for the whole read line interactive, so it's the same one getting passed multiple times, but I could mutate it, I could use a pointer, I could do any number of things, but I'm currently enjoying this style of saying like, hey, this is the new state of the world. This is where it was. I don't know. I'm currently quite happy with this. This is all all of this state stuff is pretty new as well. Mostly because the old system was just really aggravating. So I never did any of this interesting stuff with it. I used to have... Well, I couldn't do any interesting stuff. The way that this was all defined before, if we go back... Actually, we could just... If we stash this, the like 0.12.0, oh, well, that's not really helpful. Because I've reorganized since then. It's not in user, it's just the readline.c. So the way that this used to work was I had this like index and I had this buffer. And then for all of these functions that would manipulate the state, so the big ones were load history line. You can see there's no moving forward and backward because I didn't have a cursor. I just had the end. And I was passing the character pointer to the array and then the integer pointer to the index. And so like clear line is char star buff long star ix while the value there is greater than 0, like back up one at a time and print out backspace. Ditto backspace, right? If it's 0, otherwise like reach into the parent function and subtract and print out a backspace. And I disliked this so much that I just needed to change it. And that's, this is the new version. And I like it a lot more. No pointers. I think I know I'm writing C, like there's always going to be pointers, but I feel like I'm becoming allergic to pointers. Another big thing that I'm trying to do and that I might spend some time on later tonight is if we look at something like the threads, right? So this is the like separate processes and threads of execution. There are all kinds of these, what I've called lists or list n, which is like short for list node. And all of these are pointer-based linked lists that this thread is a part of. So this thread is part of a pointer-based linked list called all threads so that you can iterate over all of the threads. And it's also part of the pointer-based runnable list and the pointer-based freeable list. So this thread has like 17,000 pointers pointing to it at one time. And it's just really, it makes me so sad. I don't like it anymore. And even, right, like there's pointers here and there's pointers here that the tracer is a pointer and the trace result is a pointer, and I'm just so frustrated with dealing with problems where like, oh, well, this process was deallocated and the thread still exists. And so now the thread is just like a time bomb. If it ever gets scheduled in the future, it will try to dereference the process, and then the whole operating system will crash. And because it's crashed, it's like very difficult at that point to figure out, oh, right, well, what was that process and why did it get deallocated? And so there's just so much logic in like do thread exit to try to make sure that everything that this was doing is done, right? Remove it from all of those lists. And well, if we have an event, drop that event. And if the thread and the process are the same thing, then like set this exit intention, and we can't delete the thing, so we set it to zombie because we can't delete it until it gets waited on. And so what I've been working on is a new model for this whole thing that basically doesn't use any pointers at all. And the first part of that is my new mutexes. Instead of using wait node and a linked list to figure out who to run next, they use this integer that is basically, it's like ticket based is what I'm calling it. I'm calling it a deli ticket. So the idea is when you try to wait on a mutex, it's like you go to a deli counter and you take a ticket, and it doesn't matter if you walk away because they just go to the next one. I don't know. It's kind of slow because I have to like figure out who has the ticket, but I'm allergic to pointers. That was a long tangent to say that I'm allergic to pointers. Where were we? We were going to... what else did I wanted to do? Well, I did F and B. Ooh, should I commit that? Should commit that. I should commit this. CF and CB for Emacs readline compatibility. CB doesn't work yet. Which is the next thing that we should do. CB I use for this swap foreground serial, so you can see CB is getting intercepted right here in kernel TTY where we just were. It calls swap foreground serial, and the thing that does, that's another very recent, but like I don't know how I didn't think. I spent literally 5 years writing this operating system with basically no way to put a program in the background, because it's kind of like an annoying thing, like, oh well, I've got a shell, how do you background something without, I don't know. Sure, it's a very easy problem and I did solve it very easily, but I never had one. I had this like BG program that makes a background process that just sits there doing nothing, but that's kind of boring because it's just doing nothing. So what CB is it lets me switch. This is now a different shell. This is a different shell running on a different TTY, right? It's just, I can tell the system this is the real one, that's the real one. So like if I start AB, which is just, run 2 threads, one is printing A, one is printing B, it's a threading test. I can hit Control B, and now I'm back on the other thread. AB is still running. It's just, now it's printing to a TTY that's not going anywhere. I can go back over there. I can check on it. I can go back to serial A, back to reality, right? Where I can do things like, oh, well, let's kill 9, and oh, look, it's all A's now, right? It's just, I just had no way to do that in the past. And so I just need to pick a different, control character that's not used by the Emacs readline. How many of those are there? Control J, no. Control P, I'm already using for something else. Control O is an option. Control O in the cheat sheet. Does not appear to be used by readline, so we're gonna go with Control O. Easily done. And of course we did a commit, so we have to rebuild the whole universe. Why is it 192 now? Did I add another file? What did I do? I didn't add another file. Diff is just that. It runs. Echo. Control B works now. Control P does something else. Thank you. I'm glad to have you. I will, hopefully, I haven't been doing this very long. Hopefully I'll keep doing it. I look forward to seeing you again if you come back. Have a good rest of your day. We're going to go ahead and commit Control O. Swap. What did we call that? I should probably use the right commit name. Swap foreground serial. Change control key. CB is already claimed by readline. Let's use something that isn't. And that fixes that. So what's next? We've got Control B, we've got Control U. Control U could be really interesting. Actually, I think that's totally what we'll do. We'll do Control U. Clear line killed before a cursor. And we'll just make a function called clear line before cursor. Clear line after. Before. So clear line after cursor is really simple. You just say clear everything after the cursor and then you set the length to the cursor. I think this is going to be a little bit more complicated. For starters, after state.length minus state.cursor, then I think what we're gonna do is just, I'm trying as much as possible to avoid re-rendering the entire line because you get the you get a flash. But buff. I'll explain that better in a second. Nope, state.cursor. State.cursor after. So we're starting by moving cursor equals 0. State.length equals after. Because if you kill everything before the cursor moves back to the beginning. The length is everything that used to be after the cursor. And we want to move everything that used to be after the cursor, which is buff plus where the cursor was for however many things were after the cursor, to the beginning of the buffer. And then for now, surely that's not, yeah, that's just void. And we gotta put this up here just so that I can call it anywhere I want to. For the moment, I'm gonna call re-render, which takes the buffer too. And re-render just reprints the entire line. I have Control R wired up to do that as well. And I don't like doing that. I said it causes a flash, which I would show if this didn't have to build the whole world. If you've got a big line the text and you re-render it, you see how it like takes a moment. So sometimes you get a little flash, or if the cursor's somewhere else, right? The cursor has to move back to the beginning and then back to where you are. So it flashes a bit. So I don't like it very much, but in this case, as you see, that just like worked perfectly. The alternative to re-rendering would be, what would I have to do? So like kill after is really easy, right? Because kill after, I just send the control character that says get rid of the rest of the line. There's a control character for that. You don't have to move anything. Whereas stuff like, you know, deleting earlier in the line, you have to move everything that's after. Because a terminal is not, it's not a word processor, right? These are individual character cells that you're controlling. So if I delete a character here, it's all the rest of the line is going to stay exactly where it was. And I have to, what you have to do is delete everything the rest of the line, reprint it one over, and then move the cursor back to where you wanted it. Or at least this is the only way that I know how to do it. There may be a better way, but I've never found it. So to reprint after killing before, you would have to delete the entire line anyway. So I think a re-render is kind of like, it's not worse than it would have been. So like if I go here, Control U to kill everything before, yeah, I think that's, I basically would have had to re-implement re-render myself. Except, I mean, the only thing I might have been able to save is this, is the prompt, which may be annoying later. Like if I'm doing something non-trivial, obviously this prompt is a little more complicated to render because you don't know how many characters this is, and especially with stuff like this, the get information that may change after you print it, right? If I print this line, this prompt, and then in a different terminal I change what branch this Git repo is on, it's gonna potentially change what this text is, and then potentially change how long this is, and that kind of makes the like reprinting kind of annoying. But I'm not solving for that yet. This is a very simple shell, and the prompt is $, so I'm not too worried about it. And as far as I can tell, what I have done works. So let's look at this. We added re-render up there. We added a function called clearLine before cursor, which does exactly what I wanted it to do, and we called it in Control U. I think that's committable. That's Control U. And that I don't think needs any more explanation than that. Control P and Control N are supposed to deal with history. Those should be very easy to just copy exactly what I have in up arrow and down arrow. Control P is the same as up arrow. How is this described? This is previous command from history list. And this is Control N. Next command from history list. And that could be abstracted, right? I could have a like state equals load previous command that does this current previous and the load history line. State equals load next command. The fact that it's only 2 lines like this, I'm not too chuffed. But that's definitely like an option, something that we could do. I also wanted to do Control L, which Control L is just going to be a single escape sequence. Control L happens to be clear screen. So let's figure out what the ANSI code for clear screen is. ANSI escape sequences. Erase in display. Clear part of the screen. If n is 1, clear from, if n is 2, clear entire screen. So I suspect the answer is going to be the CSI, which is backx1b, open bracket 2j. And it would also help if I spelled clear right. I suspect that both of those will be correct. This is going to take another 100 or so years to build everything. And what are we doing? Control L clears the screen, but it doesn't actually move the cursor. Okay. Interesting. And it doesn't reprint the, okay, yeah. So I guess let's add just into clear screen, right? That literally deletes all of the contents of the screen. But the other thing we could do is default to 1 if omitted. So CSI, which is backx, honestly, I should just make a, and I suspect that's enough. Well, that's not the right CSI, but the way, so the H command is, what is this? Row N column M. So I could say 1, 1 for the top left corner, but I don't actually want to say 1, 1 because, well, you could say 1, 1, but if you omit the 1, 1, then it's the same. So why would I say it? And then re-render state. Oh, that's an interesting question though. If I have blah, 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 yeah, re-render is correct. Because it does not actually delete everything. Why is that upset? Re-render needs the buffer. Do I have a re-render here? I do. It's Control R. Buff state. Buff state. And L. L, that is the correct behavior. Perfection. And we have P. No, we don't have P. Because Control P is debugging event log status, and we just don't need that at all. y remove unnecessary cp event hog debug info. And so this is Control P, Control N, and Control L. CP and CN for history. CL to clear screen. And push those. Only other one that I had on the list was potentially to do Control W. What is Control W? Or did I accidentally press W when I was trying to do something else? Ah! Kill to the start of the current word. Interesting. W. Ooh, that's interesting that it actually jumps over the first series of spaces. So it's like a backspace. What if you have only spaces? Okay, so it backspaces through any number of white space characters to any number of non-white space characters, and then stops at the first white space character after a non-white space character. That should be pretty easy. And presumably happens in the middle. Yeah. Okay. That's going to be very interesting. We're actually going to put this up by Control K. Kill after, kill before, case, Control W. Kill word before cursor. And what we will do is we will make a function called kill word before cursor. If you are not seeing a pattern, I don't know what to say. Clear line before, but this is clear word before. So, so we're gonna want to do like a scan backwards. Scene non-white space false for I equals state.cursor. I is greater than 0 and I is greater than or equal to 0. I minus minus. So right, so we're going to go backwards from the cursor to the beginning of the buffer. If buff I is space, no, if not is space, and now if we're basically going to backspace from, so after, this is now going to be a lot like clear line before. After is state.length minus state.cursor, right? This is everything after the cursor. We're going to mem move that buff plus I, because we're moving it, we're not moving it to the beginning of the buffer, we're moving it to plus I, which could be 0. To buff plus I of buff plus cursor, and we're moving the amount that was after. The cursor becomes I. State.length minus equals remove is state.cursor minus I, and we're going to remove from length. Cursor is now I, and we're going to return state. And then, so if it never, no, it should always, there's no case where we should exit out down here, and in fact we should probably just say assert false, because it will always either, there's nothing to do, in which case return state, there's word characters and space characters, in which case it will remove one word. If there's all word characters from cursor all the way to the beginning of the line, it will remove everything before the cursor. And if it's all space characters from the cursor to the beginning of the line, it will remove all the space characters. So there should be no case where you leave this for loop not having returned here. You're either going to remove things when you see non-white space, or you're going to remove things when you see 0. So do we break? And I would do, there is a symmetric version of this, right? Right now we're going backwards. There is a version to kill forwards as well, but I'm not currently line state, clear, cursor, buff, star. Oh, because I don't rename this. There is a forward-facing version, but it uses Alt, and Alt doesn't work. So on a Mac, it's annoying to get Alt to work on a Mac, so I'm just kind of not going to worry about it. Asserting in, no, this isn't Lucy, this is application code, so it's not a huge deal. Probably. Let's see if it worked. Bunch of characters, Control W. Whoa, okay, well. I was wrong. I says state.cursor, I greater than or equal to 0, I minus minus. Why would you not? How would you not exit there? Unless state.cursor is 0. No, it should still iterate. And it's an integer, so it's not like it's all of these things are integers. It's not like this is an unsigned issue. Why would it be leaving the for loop? there's no breaks. What am I missing? I see. Yeah. It was just going through the see non-white space every time. Okay, so right now it's not doing. No, okay. Yes, it's doing exactly what it should do. It's just not re-rendering. Well, we hope it's doing exactly what it should do. It wasn't re-rendering, so there was no way to know. Okay, that's actually not quite correct. That's wrong. That's almost correct. Yeah, it's like it's behaving weird with. Well, for starters, state.cursor is not state.cursor is not valid because state.cursor is the next character to be written, right? It's like length is one past the end of the array in C. State.cursor is one past the end of the valid array. So that's part of the problem here. If this is also some like bananas logic. If is space buff I and we've seen non-white space or I is 0. Then I should be if it actually is space, we want to preserve it. If it's not space, we don't want to preserve it. Because we don't want to go all the way to, right? The challenge here is I don't want to kill the space according to the thing. I don't want to kill the space if there is a space. But if I'm back at I equals 0, so I'm just going to add the Boolean for now and add a hacky note and feel good about it. Now, else, and what's our else going to be? Right, so this else would be if it's a space, we haven't seen non-white space. I don't actually care about that, really. I just want it to keep going. But if it's not space, seen non-white space, that equals true. Maybe that makes a little more sense. Yeah, you're mad at me because you want this to be parenthesized because C is confusing, and it's a fair point, and that's why I'm not going to argue it. Control W, that put it on the correct place that time. That is all. Oh, no. That's wrong, though. So I need one more condition. S equals buff I, and I does not equals 0. I'm going to upgrade that to super hacky. Oops. Attribute, and now it's doing the right thing. Clear word. Sorry, CW. I'm actually very happy with that. And I think that's going to cut us another version. Where were we? O12.4, tag vo.12.5-m. Improvements to interactive read line. What did we say? O12.3 was interactive line editing. O12.5 improvements to interactive line editing. But that's fine. I have no complaints about that. But that's 2 items off the to-do list. And I think I'm starting to get a little tired. So I think I am going to wrap this up here. Thank you everybody who came, and thank you everybody who's going to watch the video later. I will be doing more of this, and I hope you are excited to see it. I should be setting up, I intend to save these streams, these Twitch VODs to YouTube, maybe unlisted. Haven't really decided that yet, but I do want to keep these around for future viewing, so that they don't just disappear into the ether, because I think that's a real shame. And yeah, I'll get that set up and linked, and I hope everybody has a good day. Thanks for coming by.